Hello everyone, I'm Na Meng, an assistant professor from Virginia Tech. Today, I'd like to introduce our recent investigation on NPM packages. This is a collaborative project with my students Pranoy, Seksham, Zhiyuan, and my colleague Daphne. Node.js has been popularly used for web application development, partially because of its large software ecosystem known as NPM packages. When using open source NPM packages, most developers download pre-built packages on npmjs.com or the npm.js registry instead of building those packages from available source. And then they implicitly trust the downloaded packages when building their projects on top of these packages. However, it is unknown whether the blindly trusted pre-built NPM packages are reproducible. Therefore, in our research, we were curious about two questions. First, are the pre-built packages on npmjs.com always reproducible? Second, if reproducibility is not achieved, what are the potential reasons? In this project, we conducted an empirical study to examine the reproducibility of NPM packages and to understand why some packages are not reproducible. To investigate the reproducibility of NPM packages, we first obtained URLs of 226 most popularly used packages according to the NPM rank list provided by GitHub. Each URL corresponds to a web page on npmjs.com. From each web page, this step obtains the related GitHub repository link and all published versions of this package, such as PN1, PN2, and all the way down to PNM. From the GitHub repository, we also retrieve the code commits corresponding to those published versions, such as C1, C2, all the way down to CM. Then we adopted the standard NPM build process to generate the package versions from source code commits. Theoretically, if all published versions are reproducible, the versions we generated with the standard build procedure should have bit-by-bit equivalence with the published ones. Therefore, in the third step, we used an off-the-shelf textual diff tool, diffscope, to compare each rebuilt version with a related published version. If there is any revealed difference, in the final step, we conducted a manual inspection to reason about the observed differences. So, surprisingly, we found about 38% of the studied versions to be non-reproducible. Based on our manual analysis, we classified the observed differences between versions into 7 categories. For instance, C2 means that one version has a longer expression used in an if condition, while the other version under comparison uses a shorter but semantically equivalent version. C4 means that the two versions under comparison use distinct names to refer to the same variables. Overall, the observed differences of the first 6 categories are the syntactic differences that implement equivalent semantics. However, C7 includes semantic differences. We also further investigated the build process to understand why those differences occurred. So far, we identified some reasons to explain the observed syntactic differences, such as the version relaxation of some used libraries and the distinct optimization strategies adopted by different versions of uglifairs or transpilers. In the future, we will explore why semantic differences exist between versions and further investigate whether those differences indicate any bugs in uglifairs or transpilers or indicate security vulnerabilities in NPM packages. This concludes my talk. Thank you for your attention.